So this video is about Venus, the planet Venus. Um, I spent the better part of yesterday kind of looking at the planet, its topology, um, and basically what's going to take to colonize it. So it was really interesting. Just kind of looking at the data set. The thing that kind of holds the human species back from thinking about colonizing a planet like Venus is that it's too hot. Temperatures on the surface kind of range in the regions of 450 degrees Celsius. So that's pretty hot. And if you take that one bit off, when you kind of look at a problem, then everything else looks pretty good. Its gravity is somewhat closer to the kind of gravity that's on Earth. 9.8 meters per second square on Earth. It's 8 something on Venus versus 3 something on Mars. The surface area is close to zero point 0.9 Earth, so almost like another Earth in terms of surface area that's available, versus 0.3 when it comes to Mars. It's closer to Earth compared to Mars. So there's a lot of similarities if you can somehow figure out how to control the temperature on the surface. Now there have been some hypotheses where some people have kind of the ideas kind of be floated, pun intended, that you can have colonies in this part of the atmosphere where the temperature is just right. So 55 kilometers in the atmosphere from the surface. The temperature is, if I remember correctly, 27 degrees. So that's ideal, right? You have this zone in the atmosphere of Venus where the temperature is just right. So some people kind of pitch the idea that you can have floating cities or like large floating structures that would basically be a planet colony of sorts, or on Venus. So I actually spent a lot of time looking into this yesterday. The thing I didn't realize is that I tried to solve two problems. One was the thinning of the atmosphere. So my hypothesis was if you kind of somehow come up with a mechanism to be able to thin the atmosphere, then you can make it less dense, because the reason why Venus is so hot is because the gases get trapped in the greenhouse effect. It's like really cooks up the planet. It's kind of what's slowly happening to Earth, but that's climate change is another conversation. The other problem I kind of looked into was volcanoes. So isn't like really, I gotta look into that a bit more. We need to send more probes on the surface basically to be able to figure out how many volcanoes are active on Venus. But I think based on what I found on NASA's website, at least 1,600 major volcanoes may be present on the surface of Venus. There's a lot of other smaller ones, hundreds of thousands of them. So it's not humanly possible to be able to kind of go in and plug each one of those volcanoes. But there is a way to basically drill a shaft in a tube in a fissure from where the lava comes from, and basically collapse it. So you just kind of have the whole volcano fall upon itself without destabilizing the surface. So in short, there are ways to contain volcanoes. It's never been tried to the best of my knowledge. And that's just one of the many ways. There could be more, right? So in a future scenario, so like this is again like 10, 15, 20 years out. But with the acquisition of advanced technologies in the realm of material science, You could just kind of send robots, and they would somehow be able to turn matter around them into something else, and basically plug the fissures. That's just two of the many ways they could do this. Um, but yeah, so those are the two problems I kind of looked into. Um, the one thing I failed to mention is another thing that's really ideal about Venus is something called atmospheric escape, which is the loss of planetary atmosphere gases to outer space. So Venus actually sits in a really nice spot, according to Wikipedia at least. Uh, Atmospheric escape is kind of determined by the actual size of the planet, the way I understand it. So it's all got to do with gravity. So it's actually gravity that holds the atmosphere together. Um, and the bigger a planet is, the higher its atmospheric escape is going to be, or lower actually. So bigger planets like Saturn, Jupiter, um, Uranus, Neptune, they kind of sit in this higher zone, and Earth and Venus sit in the middle, just in the right temperate zones. And Mars, Ganymede, Titan sit in the next zone, and then smaller planets like Mercury or Moon, Callisto, Europa, Triton, Pluto, they sit in the lowest zone, where the atmospheric escape, the way I understand it, is higher. So, that was another thing that kind of really kind of made me kind of look into this from the perspective of if we solve those two problems, then we could have another planet for colonization. And there's like I said, there are many other benefits whereby our evolution is going to be very close to the kind of evolution that we have here on terrestrial Earth. The thing I didn't realize, though, before I get into the actual like what I was thinking in terms of the solution, the thing I didn't realize is the magnetosphere. So that's something I've got to look into. I got a couple of tweets this morning because I kind of sent out a couple of tweets related to colonization of Venus last night. So it's like this one guy kind of pointed me to the fact that the thin magnetosphere is something that's got to be considered when it comes to any plans when it comes to colonization of Venus. So you kind of share some ideas of how you could do that. Shared one idea at least. It's like you can bombard asteroids with a high kind of water content into or comets or asteroids, a combination onto Venus, and basically there's something else he mentioned. What exactly was it? So you bombard the Venus surface with H2O and iron ore meteors for 1,000 years. You concentrate the core temperature, liquefy, and create magnetic field. It's like too long of a time frame. The 1,000-year roadmap for colonization of Venus sounds too long. And so I guess my question at this point is how necessary is the magnetosphere or the magnetic field? Could we not just kind of work on those two problems that I've shared, as in bringing down the temperature in the atmosphere and containing the flow of the volcanoes to a manageable level? And doing those two, we're going to be able to bring the temperature down at some level. I don't know how long it's going to take. I think it's going to take a couple of decades, but or maybe less. I don't know. But by doing that, we can effectively start building settlements that are kind of like geodesic domes or maybe underground facilities, depending, like, the surface is not too hot at that time. And that would be the start when it comes to the colonization of planets like Venus. So the two ideas that I was thinking of, that being said, like the whole And so my other question is, which I'm going to look into, if the magnetosphere or the magnetic field is actually required, then wouldn't it be the same for something like Mars? How are we planning to do that on Mars? So it's going to be interesting to borrow some of those elements from Mars and just kind of replicate it for Venus, as in with a lot of other solutions or sub-solutions. So the idea that I was thinking of was, it's a really simple idea, but basically what you do is you build a space station around Venus, and what it does is it sends this tube down in the atmosphere, and the tube is going to be made of carbon nanotubes or graphene. And basically what it does is it sucks up the carbon from the atmosphere. And Venus has got a very high concentration of CO2. Earth's got 0.03% carbon, I guess, and Venus has got it in the early, I think it's 92 or 93% concentration of carbon dioxide in its atmosphere. So what we basically do is when we send this tube, this massive tube, mega structure down Venus's atmosphere, we sequester the carbon right there, as in suck it up, sequester it, and send it up some shaft. It could be a combination of things. I think the most feasible would be just like some kind of a space elevator hanging down from the space station, or it could be something else. I don't know if John Hunter's space gun would work in this case. It's an option worth entertaining. But you basically sequester the carbon, you send it up, and based on the sequestration, what you do with all the sequestered carbon is that you use it to create an artificial moon around Venus. And you basically expand the operations by sending blimps into that ideal zone. You send a lot of these blimps. You can just 3D print them right there on the space station around Venus. And you send like thousands of them in the atmosphere. And they do the work of the minions, where you have this mega kind of structure doing the sequestration. But in terms of the multiplier effect, because all they really need is sunlight, and the sunlight is available over the cloud structure, right? So they can just kind of float about all day long, and they can attach back to the mother structure at the end of the day, just like through some magnets or through any contraption. But you have this multiplier effect going. You kind of keep printing them, keep sending them down, and they keep doing the work. They keep replicating in terms of, you just kind of 3D print them, and they do the effect of what basically it's a multiplier effect. So that would be one way to kind of put the lid on, or just kind of contain all that carbon on Venus. The other idea that I thought of was more in terms of just kind of containing the volcanoes. So I kind of started looking at metals, which could help us create alloys, which would have a higher melting point, because the surface can get pretty hot on Venus. It's in the high hundreds. I think it was 900 Fahrenheit or something like that. So if you got some kind of you got some kind of metallic structure whereby you can create alloys out of it, which would have a really high melting point, then you can create robots basically that can go into these hot zones and plug the volcanoes. So to fix that problem, though, you need to go beyond the realm of the space station itself. This is where the solar system-wide ecosystem comes into effect, because I don't think you're going to be able to mine the actual metals from Venus itself. So you'd need to kind of bring it in from an asteroid or somewhere else. You would manufacture them on the space station and 3D print them, and they'd basically go to work. Depends on how quickly you can do that. I mean, there's a lot of things. There's a lot of problems to be worked here. You need energy systems of different sorts. You need propulsion. You need some kind of a solar system-wide framework emerging for transportation, whatever it is. If it's rockets or ion thrusters or something else. So you basically have these things going from one point to another, and kind of share a glimpse of this in a blog post I made on my blog at theocon.ca. Call it the 7 stages of space exploration and mining. So I think this would kind of sit somewhere in stage 3. It would be part of stage 3. But I don't see any roadblocks per se that would prevent us from kind of tapping in or turning Venus into another Earth. And it looks like a really kind of look like one of those undervalued properties where nobody's paying attention, and you kind of change one house and changes the entire neighborhood, right? It's like a ripple effect. The problems are not that hard. It just requires that we push some technologies, and it requires the infusion of capital, and it requires the collective will. But if we keep complaining that we're running out of resources and population is growing, let's go create another Earth. It's right there. It's some 20 million or 25 or 26 million miles away, and all the pieces are kind of fitting together. Launch. Look at what SpaceX is doing. It's remarkable. Look at what Blue Origin is doing. The price to send a pound of weight to space is going to come down substantially. Technology is going to have a democratization effect. More materials and resources are going to be available. So it's time to dream a little bigger. And I think beyond Mars, we should think of colonizing many other places in the solar system, not just Mars and Venus. The different asteroids for like mining facilities and scientific outposts. Maybe a small settlement on comets somewhere. Europa has always been interesting. A lot of water there. It's like many places to go. It just requires for us to take the first step. So I'm not saying take the focus away from Mars. Mars is equally important. I think we should start looking into Venus as well at the same time. So I'm not getting into how this is going to be done from a wider strategic perspective. But this is my case for Venus and the 2 problems that I think stand in the way of us colonizing that planet. And we gotta just think of the magnetosphere problem now. Thanks.